Hello, in this video I will solve a Bertrand question with two firms and they will be asymmetric firms and they will have increasing marginal costs. So let's start with the setting. So we'll have two firms and firm one has a cost function given by just q squared. So nice convex cost function. Firm two will have almost the same function but divided by 2, so firm 2 is more efficient. The market demand is given by some linear demand function, 5 minus p. So our firms will be picking quantities here, and we actually will solve a lot of things for this setting, and we'll start with a perfectly competitive outcome for comparison. So perfectly competitive outcome. To find perfectly competitive outcome, we need to calculate supply curves for each firm, and that's using standard condition, price equals marginal cost. So for firm one, it will be its marginal cost is 2Q equals to price, therefore its supply will be given by P divided by 2. And as this is for any price, this firm doesn't have any fixed costs, and the marginal cost starts at 0, therefore supply curve will be P over 2 for any P. For firm 2, symmetrically, marginal cost will be just Q equals to price, therefore its supply curve will be just P. So aggregate supply then for two firms is P over 2 plus P, and then we get 3 to P. Okay, then for perfect competitive outcome, now we have a supply, we have a demand function, we just intersect those. So for P star, we have 5 minus P star equals to 3 over 2 P. So then we get 5 over 2 P star equals to 5. And from here we have P star equals to 2. So we find the price that will be in a perfectly competitive outcome, and we can use this price to calculate other information that is asked in this question. So for example, firm 1 will produce 1 unit, we just plug price in here. Firm 2 will produce 2 units. Overall production will be at 3. Market price is 2. Let's calculate profits. So for firm 1, it will be, it sells 1 unit at a price of 2 minus the cost of producing 1 unit. So it's just 1. P2 star will be, it sells 2 units at price of 2, so it's 4 minus cost of producing 2 units is 2. Therefore 2. Producer surplus will be then just the sum of two profits here. It's 3, and consumer surplus is, just recall that our inverse demand is 5 minus Q, price is 2, starts at 5 here, and our quantity is 3. Therefore, we have a triangle with a size of 3 and 3, so consumer surplus must be 4.5. Here, just a half of the 3 by 3 square. Okay, so that's our perfectly competitive outcome. Yeah, social welfare is just the sum of these numbers, so 7.5. Okay, so that's the first question, and now we'll continue solving effectively. We'll continue to work with the setting, and we ask a question: if firm 1 were alone in this market, what price will it charge, and what is the minimum price it can sustain in this market? What the minimum price at which it makes it zero, effectively non-negative profit? Answering these questions will help us a lot when we actually start analyzing the Bertrand model, where firms competing picking prices. Okay. So let's continue. And so firm 1 alone. So now first let's solve for the price it actually wants to charge. So that will be obviously the monopoly price. So let's find that. So for monopoly, the rule is marginal revenue equals marginal cost. We already know what marginal cost is. Let's figure out the marginal revenue. Inverse demand is 5 minus Q. Therefore, revenue is Q times P of Q. And marginal revenue is, if you calculate it, it will be 5 minus 2Q. So just take a derivative of this. Then to find monopoly quantity, we need to equalize 5 minus 2QM equals to marginal cost of firm 1, which will be 2QM. Therefore, QM will be 5 over 4. And the price, the one we were looking at, PM, the one we wanted to find, is given by plugging the QM into the inverse demand. So PM must be 5 minus 5 over 4. So it's 15 over 4. So it's 3 and 3/4. Or it's 3.75 if you wish. Okay, so that's a monopoly price for firm 1. So if firm 1 is alone in the market, that's the price it will select. Now let's solve for the minimally profitable price. So if firm offers price P, then it will sell according to the demand function. We get 5 minus P into the demand. And then its cost of servicing this market will be minus 5 minus P squared. So that's a profit function of the monopoly for the first firm. And we want it to be greater or equal than 0. So we're solving for all these prices which are profitable, but effectively we're just solving for the price set such that the profit is equal to 0. Okay, so I can divide by 5 minus P without changing the sign. So get 5 minus 5 minus P greater than 0. So we get 2P minus 5 greater than 0. And so we get P greater than 2.5. Okay, so for firm 1, we know that it wants to be at 3.75. The lowest price it can sustain when it operates by itself, so it actually covers all demand, is 2.5. So now let's repeat the same steps for firm 2. We'll just do it quicker, since we already know majority of the numbers. So if our firm 2 operates alone, it will set also marginal revenue equals marginal cost. So marginal revenue for this firm will be the same, of course, because it's driven by demand. What changes is the marginal cost, which is just Q. Therefore, QM for firm 2 will be 5 over 3. And therefore, PM will be 5 minus 5 over 3. So it's 15 minus 5, 10 over 3. So that's effectively 3 1/3, or 3.33. Okay. So notice that firm 2 will charge, its monopoly price is lower, makes sense because its costs are more efficient. And now we need to solve for the break-even price. So P2 of P will be firm 2 operates alone. It services the same market by itself, but its costs are better than that of firm 1. So we will get a different inequality. So again, we will divide by 5 minus P. We'll get 5 minus 2.5 plus P over 2 greater than 0. we get 3 over 2p. We get on this side 5 over 2. So p must be greater than 5 over 3. So that's 1 2/3, which is 167. Okay, so that's the lowest price that firm 2 can sustain. So let's actually record this information somewhere for ourselves. So let's do it here. So for firm 1, the price, when it operates alone, it operates between 2.5 and 375. It doesn't want to go higher than that because if it's alone, this is a monopoly price, this is the lowest sustainable price. And for firm 2, these numbers are 167 at the bottom and 3.33 at its monopoly price. Okay. Now, now we'll be solving for symmetric Nash equilibrium, and we will look for equilibria. So we'll be looking for Nash equilibria such that firms charge exactly the same price. So they will be charging the same price, and according to standard Bertrand rules, they will both have sales. They will split the demand at that price 50-50. So that's what's going to happen. Let's find the ranges for the Nash equilibria. So when we are operating in this, when both firms charge the same price, it won't be a Nash equilibrium if one of the firms making negative profit. So the price has to be such that both firms are making 0 or more. So let's check for firm 1 what kind of constraint it will generate for us. So firm 1 charging price P, it will get the price P. It will get half of the demand at that price. And its cost will be coming from servicing half of the demand. So half of the demand is 5 minus p over 2, and I need to square it. So that's why it's 4 here. This has to be greater than 0. So again, we cancel 5 minus p. We'll get p over 2 here, minus 5 minus p over 4 here. So let's multiply it further by 4, get 2p minus 5 plus p greater than 0. So 3p greater than 5, p must be greater than 5 over 3, which is 1.67. Okay. So notice that when firm 1 was alone, it can only sustain a higher price. But in a Nash equilibrium, because it shares the sales, its costs are not as high, therefore the price can actually be lower and still be sustainable for firm 1. So that's 167. So let's start capturing it here. So it's from 167. And the upper bound now will be, so the upper bound will be given by no undercutting condition. So what's going to happen in Bertrand, because we will typically be naturally operating below the monopoly prices, and the main incentive for the firm will be to undercut a little bit and steal the market, so increase its sales effectively twice, while still effectively keeping the same price. So firm 1 would not engage in undercutting only when its current revenue, which is already written higher, is better than its revenue from literally charging the same price and servicing the whole market just by itself. So P5 minus P minus 5 minus P squared. So this is what will happen if firm 1 undercuts firm 2 and charges slightly lower price. it will get effectively this profit minus a very small amount, and the small amount can be made arbitrarily small because the undercutting can be arbitrarily small. So that's why this the highest price has to be given by this expression here. Okay, so let's solve it. So we cancel 5 minus p on both sides. So what do we get? So here p minus 2 minus 5 over 4 plus p over 4 greater than p minus 5 plus p. So let's multiply everything by 4. So 2p minus 5 plus p. Here we'll have 8p minus 20. So let's see. 3p, 8p, so we'll have 5p on this side. Sign will change, and on the other side we'll have 20 minus 5, so 15. So p must be less than 3. Okay. So effectively, if price is below 3, if we're in this range somewhere from 2 and from 1 and from 2 sitting in this range at the same price, then from 1 is profitable, and it doesn't have any incentive to undercut because it actually enjoys a bigger profit by sharing the market with firm 2. So now we have to repeat this exercise for firm 2. So let's so that was firm 1, and let's do firm 2. Okay, so okay. And we go through the same steps. First, we derive a condition at which firm 2 is profitable. So it charges price P, it gets half of the market, and it has to cover its cost. And its costs are 5 minus P squared over 4, and this 2 is from here. So, so this thing has to be greater than 0. Therefore, let's divide by 5 minus p and multiply everything by 8 as well. So we cancel this, we cancel this. We get 4p minus 5 plus p. And then 5p, so it has to be 5p greater than 5. P has to be greater than 1. So for firm 2, similar story. Its minimum sustainable range actually went down because it's sharing the market, so its costs are not as high. Marginal costs are increasing, so your cost for serving small amounts are disproportionately lower than for serving higher end of the market. Okay. Finally, no undercutting condition. So again, we write profit of firm 1, firm 2, p5 minus p over 2 minus 5 minus p squared over 8 has to be better than if it just serves its whole market by itself. So this is sales minus the cost over 2. Okay, so canceling 5 minus p and multiplying everything by 8, 4p minus 5 plus p, 8p minus 20 plus 4p. Okay, so 4p cancels out. So we have 7p on this side, and we have 15. 20 goes here, so 15 on this. So p has to be less than 15 over 70, which is approximately 214. Okay, that makes sense. So 214. Okay, so now we actually have all the numbers to describe the Nash equilibrium set. So for symmetric Nash equilibrium, where firms charge the same prices, so P1 equals P2 equals to P exist in this model as long as P belongs to the following range. So it has to be sustainable for both firms. It's sustainable for firm 1 above 1, sustainable for firm 2, 167. So we take the highest one because it has to be sustainable for both firms at the same time. So on this end is 167. And both firms should not have incentive to engage in undercutting. So this firm doesn't undercut below 214. This firm doesn't undercut below 3. Therefore, we take the lowest of this, 214. So here's the range for which the Nash equilibrium exists. Now we have a quick question there. Does our competitive outcome belongs to this outcome? And actually, yes, competitive outcome was, remember, P star was equals to 2. Therefore, it's squarely in this range, as typical for Bertrand models. Okay. And finally, two standard questions. So let me erase my calculations. So the next question is whether it's possible to have in this model Nash equilibrium of different form. For example, if Nash equilibrium where price charged by firm 1 are less than that of firm 2. So typically, this kind of models do not have this equilibrium, and this will be the case here. So let me quickly make this argument. So for this to be Nash equilibrium, both firms should not be deviating. So, so for firm 2, notice that firm 2 charges some price, and since it's below P1, it's either can simply increase its price, and usually it's will lead to increase of her profit, or for it not to be so for it not to have an incentive to increase the price, it has to already be sitting at its monopoly price. So the only possibility for firm 2 not to be deviating here is when P2 is equals to its monopoly price, which something we found before, 3.33. But then obviously, so if P2 happens to be this and P1 is bigger than that, then firm 2 would not have incentive to move because it's already sitting at monopoly price. It's perfectly fine. Notice that for P1, obviously it's sustainable to charge some price below 3.33. It's somewhere in the middle, and make a positive profit. Currently, firm 1 doesn't make any profits. So so if P2 is here, then firm 1 would deviates anyway. So this is type of argument you do to show that it's impossible to have these types of situations. So it's either immediately firm 2 would increase its price, or if firm 2 doesn't want because it sits at monopoly price, then obviously firm 1 would want to deviate. And symmetric situation, if firm 1 charges a lower price, this actually makes even less sense because firm 2 is the one who's more efficient. So if we were to expect something like that, we would expect it in this direction, not in this direction. So again, similarly, if P1 sits below, then either P1 can increase price, so P1 has to go up, or P1 is already at monopoly price at 375, but then P2 will go down and deviate, or no such equilibrium here. So the set of Nash equilibria, symmetric ones that we found, is the only Nash equilibria of this model.